with the concept of still tangent to a point on a line. Now, we know very well from previous discussion that if there is a point lying on a curve or in any function, then if we draw a line tangent to that point, that is the first derivative of that particular function. If the tangent line is horizontal, meaning parallel to the x-axis, as shown here in this illustration, like for example, in this point, labeled or colored violet, that is f prime of x, then the tangent line that passes through that point is horizontal. If the tangent line is horizontal, the first derivative is equal to 0. Now, take a look of this one. We have 2 points labeled or colored violet. So this one, if you draw a line across this point, it's a horizontal line. Another line across this point is another horizontal line. So these 2 points are what we call the maximum and minimum values or maximum and minimum points on the curve. This maximum point, when you draw a line across this point, the slope would be 0. And we know that the slope of the function is the first derivative of the function. That's why we can equate the slope equal to 0, or we can equate the first derivative to 0 and solve for the value of x. So in this case, if this is our f of x and we get the first derivative, we equate the first derivative to 0. Okay, that's why it's equated to 0 here, and then solve for the values of x. These are what we call critical points. When x is 0, what is the value of y? Okay, you can solve for y. When x is 2, what is the value of y? See? So when x is 0, this is 0, this is 0, therefore y is 1. So this must be 0 and 1. When x is 2, this is 8 minus 12. So that gives you negative 4. Plus 1, that gives you negative 3. Right? Okay. So these are what you call the critical points. Ayan, class. So this is further illustrated by this one. And so we will apply this in a problem. Problem here, find 2 non-negative numbers whose sum is 9, and so that the product of one number and the square of the other is maximum. Now reflect on this maxima-minima problem. Okay, take note of the following steps. The first one is to translate verbal statements into numerical statements. So like the problem that we had a while ago, numbered problem, you're going to translate the one statement there that you're given 2 non-negative numbers. So let x be the one non-negative number and let y be the other non-negative number. So you will make assumptions. And then you identify which is the dependent variable and which is the independent variable. You also read about another statement. The sum of 2 numbers is given to be 9. Therefore, that is one clue that you can generate an equation from that statement. Numerically, algebraically, you can say, or you can write x plus y equals 9. Okay, so x plus y equals 9. You call that equation 1. And then We wish to maximize the product. And the product is that one number and the square of the other is maximum. Meaning to say, the one that should be maximized here is the product, not the sum. The sum is given only to be able for you to substitute, because there has to be only one independent variable and one dependent variable. Notice in equation 2, you have two independent variables. So you have to eliminate or substitute using equation 1 either x or y, so that what's left for equation 2 will be the dependent variable p, and then could be that you replace your, let's say in equation 1, you solve for x, and so you have 9 minus y. And you replace your x with 9 minus y, and then you multiply with y squared. So that would be your working equation. Working equation. This is where you start deriving. That's why it's very important for you to identify step number 3, which variable to be maximized or minimized in the problem. Not in this problem that we're talking here, we're not maximizing the sum, we're maximizing the product. So the P is the one to be maximized. And P should be expressed either in terms of X or in terms of Y. So number 4, as I have said, there should only be one dependent variable and one independent variable. Then number 5, you derive the working equation. And then equate that to 0 and solve for the value of y in this case. And then finally, after knowing the value of y, you can go back to equation 1 and solve for the value of x. Now you know the variables to be the non-negative numbers, which can give you the maximum product given that the first number is multiplied to the square of the other number. So these are the steps basically when you deal with maxima-minima problem. So let's start by showing you the solution to problem number 1. So when you solve a problem, you have to start with the given information. The given information is you have two non-negative numbers. The product of these two numbers is 9. So meaning to say you can write x plus y equals 9. Given that let x be the first non-negative number. And then let y be the second non-negative number. And also, another clue that was given, the product is given by the equation x times y squared. Then you write what is required. The required is that find these two. So what is x and y? And then you start solving. So we have here equation 1. This is equation 2. And so given from our steps a while ago, there should be only one dependent variable and one independent variable. So we solve for, let's say, x from equation 1. So from 1, we have x equals 9 minus y. And substitute 1 in 2. So we have p is equal to 9 minus y, y squared. You can distribute y squared. So you have 9y squared minus y cubed. This is where you start deriving. Derive. So dp dy is 18y minus 3y squared. Equate this to 0. So in equating to 0, we have a common factor y. Actually, 18 is divisible by 3. So you could say 3y. And so 18 divided by 3 is 6 minus y, right? And by zero product property, can you still remember? Using zero product. In property of real numbers, using zero product property, we can solve for the values of y. And so the values of y, we have 3y equals 0. And the other one, 6 minus y equals 0, giving you y equals 6. Right? Mom, what if instead of having x equals 9 minus y, I want to use y equals 9 minus x? Am I going to arrive on the same answer? Yes. Your p in this case would be x times 9 minus x quantity squared. And so you expand this, you have x times 9 times 9 is 81 minus twice the product of the first and second term. So that's 18x and then plus x squared. Okay, so that is, and then you distribute. So you have 81x minus 18x squared plus 18, one is x cubed. And this is where you start deriving. Once you derive that, I'm going to write on the other side, okay? I hope you don't get confused. I'm going to write this way, this side here. Just to show you it will be the same. So deriving dp dx this time instead of dp dy. So we have 81 minus 18 times 2 is 36x and then plus 3x squared. Equate that to 0. This is divisible by 3. So 81 divided by 3?
27 po.
27, very good. Minus, this is 12x plus x squared equals 0. I think this is factorable. Maybe we can have 27 is 3 times 9. So we could have 3, 0. So we have two values of x, isn't it? So x equals 3 and x equals 9. If x is equal to 9, it cannot be because the sum is already 9. So this is disregarded. Okay? X cannot be 9 because in that case, y would be 0 and the product will not be maximum. So x should be 3. So that the first method that we have, we arrive at y equals 6. In the second method, wherein we express our p in terms of x, we arrive at x equals 3. Whichever method we use, we arrive on the same answer because in the first method, if y is equal to 6, solving for x in equation 1, right here, we have x equals 9 minus 6. So x is equal to 3. Okay. In the same way, from here, we can also solve for y. And when x is equal to 3, this means y equals 6, right? So whichever method, whichever variable you choose to represent your p, you will arrive on the same answer. And what do you think is the product? The product that is maximum given our p equals xy squared, that should give us 3 times 36, and that is 108. Isn't it? Okay. So any question, class? All right. It's our rectangular pen. And so with three parallel partitions. So we can say these are the three parallel partitions. Okay. Using 500 feet of fencing. So your material, this is what's given. You have 500 feet of fencing. Question is, what dimensions will maximize the total area of the pen? So this is what is required. So in this case, you are going to find x and y. Now, where should we start? This is our solution. If x be the length of the pen, this must be x here. This should also be x. And this must be y. What equation is useful here? That means we'll call that total material. So again, we also have to let P be the total length of material, and that represented by 500. So let P be equal to 500, and that should be, how many x's do we have? First, plus the partition, we have 3x, right? So this gives us 5x plus 2y, that's 500. And so let's call this equation 1. But that is not the representative of what is required, because what's required is find the dimension that gives the maximum area. Aside from, okay, find the dimension of x and y in this case, that gives maximum area. Therefore, we have a quantity area, and that is given by, represented by the product of x and y, class. Diba? Area is length times width. So you have two variables here, x and y. Again, we make a representation of either x or y. The same with what we've done in the first problem. So therefore, maybe from equation 1, if you want to represent x in terms of y, you can have 5x equals 500 minus 2y. Or if we divide both by 5, you can say x is equal to 500 divided by 5 is 100. Right. So this should be 100. So you can distribute your y, 100y minus 2 over 5y squared. This is your area. And from here, you can Now start deriving. You could write dA, d, because we represented area in terms of y, you can write the derivative of area with respect to y equals 0 because we're maximizing it. And what is the derivative of 100y? It's 100. Derivative of 2/5 y squared is 2 over 5 times 2y. So this gives us 100 minus 4 over 5y. We will multiply both sides by 5. So we have 500 minus 4y. And from there, maybe we can solve for y. So we have 4y equals 500. Divide by 4 gives us y equals 125. What's our unit? Don't forget. Our unit is given in feet. So this is in feet. That means for this given problem, our y is 125, which brings us to the value of the x using equation 1. So, or you could also use this. Solve for x. X therefore, okay, therefore, x is equal to 100 minus 2 over 5 times 125. That gives us x as equal to this, right? Therefore, we have solved the dimensions that gives us the maximum area. So with y equals 125 and x equals 50, our area that is maximum is 6,250 feet. All right? So that solves our problem for problem number 2. Question, please. We have an open rectangular box. So we draw. This is part of our problem, to draw a box. It is open, all right? A rectangular box. So we make an assumption. Let x be the sides of of the bottom part of the box. So therefore, since bottom is a square, then this should be x and x. That's the material. Once again, related to problem number 2. However, in problem number 2, what is asked here is only one unit of length. So in this case, we use the unit feet. This involves length. In the third problem, it involves the area of the material to be used. Meaning, if you have a material, say a cardboard, you need to build a box having this area. So since this is, let this be y, let y be the height. Okay. And so this is open. When you build this particular box, what you need is the areas of these 4 sides. And so area of the sides would be x times y times 4. Isn't it? Right? And the area of the bottom part, because it's open at the top, is simply x squared. So the total area would be x squared plus for xy. Okay. And the area is given. It is equal to 48. And what is to be maximized? What's required here? What dimensions will result in a box with the largest possible volume? Right. So your solution start here. Let this be our equation 1. And our equation 2, what's our working equation? What's the volume of this box? Of the box is length times width times height. In this problem, the volume of this particular box is x times x, okay, times y. This means x squared y. Now we have equation 1. Let this be equation 2. From 1, we have x squared plus 4xy equals 48. We know that we have two independent variables here. So we have to represent one, either x or y, in terms of the other. You can solve this in two ways. Either you represent v in terms of x, or you represent v in terms of y. So what is it? Solve equation 1, solve for y. So y is 48, right? Minus, so solve for y, we have 4xy equals 48 minus x squared. Divide by 4x, divide by 4x. That gives us y equals 48 over 4x, or 48 is divisible by
12 po, ma'am.
4. So that gives us 12 over x. Minus, we have 1/4 of x. We have x squared, and then we multiply that by 12 over x minus 1 over 4x. And then distribute. So we have 12x, right? Minus, we have 1/4 of x cubed. So this is where we start deriving. dv dx equated to 0 is equal to 12 minus derivative of x cubed is 3x squared. And so we have 12 minus, this is 3/4 x squared. Solving for x squared on the other side, so it is equated to 12. And then we multiply both sides by 4/3. Isn't it? So what's left is x squared. Ito is 48 over 3. What is 48 over 3? That gives
16
us
po.
16. And so get the square root of both sides. Get the square root of both sides. And the answer would be our
4.
x. Okay. X squared is equal to 16. Therefore, x is equal to plus minus 4. Of course, we use x equals 4 feet because there's no dimension that is a negative, right? So therefore, we have a value of x equals 4 And from equation 1, right here, we can solve for the value of y. Or from here, this one, y is 12 over x minus 1/4 of x. From that is 4, 12 over 4 minus 1/4 of, so we have a value of 3 minus 1. Y therefore is 2 feet. Okay, so our dimensions for this particular box is x equals 4 and y equals 2 feet, which gives us maximum volume. Therefore, volume max is x squared times y in this case. So we have 16 because our x is 4 times 2. So that gives us 32 square cubic foot, right? So that is the answer to this problem. We have here a cylindrical tank. I'm going to draw a tank. I call this a tank because this is not just a small can. When you say can, the dimensions involved here is not referring to a can because we have here 20 pi cubic meter. This must be a tank. So I call this cylindrical tank, which holds a volume. So this is what's given. Volume is 20 pi cubic meter, right? And this is involves cost. Now, the material at the top and bottom. The material. What's the material at the top? What's the shape of the top part of the can or the tank? When you're going to construct a material and produce a circle, what is the area involved here? Area of what?
Area of circle po.
Yes, equal to
Pi r squared.
Pi r
Pi r
squared.
squared.
pi r squared. Meaning, we have here two areas, top and bottom, right? So the cost for the top and bottom would be 2 times pi times r squared times the cost, which is $10, okay, per square meter. So that's the cost for the top and bottom of the tank. Now for the sides. How are we going to compute for the side of the can? Say this is radius. We label, this is the height. For the side of the can. What's the area? We will use what background concept in solid mensuration are we going to use to represent the area? We're talking here of area of the sides.
Circumference times the height po.
Yes, very good. The area of the side would be the circumference because this represents meron kang particular length dito. Length. Length of one side is 2 pi r, which is the circumference of the circle. And then times the height. Times the height. All right? And you multiply that with the cost. And what is the cost of the side of the material? It is $8 per square meter. Therefore, the total cost of the material, which is what is being asked, what is actually required, is to find the quantities, find the radius and the height that is most economical, meaning minimum cost. So you total this two, this one, and this. Total cost, therefore, is 2 pi r squared, but 2 times 10 gives you 20. So 20 pi r squared plus 2 times 8 gives you 16 pi r h. Now, we have two independent variables. What should be our independent variable? Where do we get the representation of our variable, h or r? Because we are going to derive our cost in terms of that unchosen independent variable. We have to represent either the height or the radius in terms of the other one. But my suggestion is to represent the height para mas convenient isolve ang equation. Represent the height in terms of r rather than r in terms of height because the r is being squared. What do you think? From what equation?
Volume po.
Yes. What's the equation of the volume?
V is equal to pi r squared h.
Pi r squared h. Right. Volume is equal to pi r squared h. We use that and solve for the h. H, therefore, given that the volume is fixed and volume is actually equal to 20 pi, so volume over pi r squared. But what is volume? 20 pi divided by pi r squared. Therefore, height now, cancel this. Height, therefore, we can replace our height as equal to 20 over r squared, right? So, we can now start deriving, or we can also write muna, just to be clear. So, the cost now is 20 pi r squared plus 16 pi r times 20 over r squared. But we can also cancel out the r in here. So, what's left again? We extend our equation in a much simple expression. We have pi, and so 16 times 20 is, by the way, 320, right? 320 pi over r. Okay. So this is where we start deriving dct over dr equated to 0. So derivative of 20 pi r squared is 2 times 20, that gives us 40 pi r plus, okay, we will write 320 pi. And what's the derivative of 1 over r? Derivative of 1 over r is, diba, we can write this as derivative of r to the negative 1. And the derivative of that is negative 1 r to the negative 2. Right? So what do we have? We have negative 1 over r squared. Equate that to 0. We have a common factor here. We can factor out 40 pi. So what's left is r minus this time. Okay, minus 320 divided by 40 is 80, right? Correct?
8 po, ma'am.
Oh, 8. 8. And over r squared. So how do we solve for the r? We can multiply both sides by 1 over 40 pi. So mawala na yan. So 0 pa rin to. We have r minus 8 over r squared. And we transpose 8 over r squared to the other side. And we multiply both sides by r squared. So we have 8 equals r cubed. We get the cube root of both sides. So cube root of 8 is 2. Therefore, we have a value of r equals 2. Okay? And with that, using equation, this one, h equals 20 over r squared, isn't it? We can compute for the h, 20 over 4, and that gives us 5. Therefore, we could say that, right? And our height is 5 meters, giving us a cost that is maximum. From our equation, we have 20 pi times 2 squared plus 16 pi times 2 times 5. So this is 40, no, 8, 40. This is 4 times 20. So this is 80. 80 pi plus, this is 160 pi. So giving us how much, class? 240. This is 3.14, right? So more or less, it gives us a value of 754 USD. That's the total cost. Okay. All this are clear. Number 5. We have a piece of cardboard. I think this is one. This is among the problems I gave in the problem set. And this one is a classic problem. This was given during the board exam of CE. Paulit-ulit lang. Dumalabas siya. A piece of cardboard. You're given a cardboard. So this is 3 feet. This is 4 feet. I'm just going to give you an introduction of this. You have to cut equal corners out of the sides. So equal squares. So let this side of this square be equal to x. So let this be x, this one should be x. Ika-cut mo yan sa 3 by 4. Para when you flip this side here up, you'll form a box, an open box. No? Yan, somehow it should be like this. And once you flip this upwards, you will have a height equal to x. This one here, this side here, this is what is this side. And this is 3 minus x, 2x. If this is 3 feet, then you cut 2 x's. So this is 3 minus 2x. And this side here, which should be the side here, this is 4 minus 2x. Right? 3 by 4 feet. And you have to cut squares in each corner. So that's what is given to form a box. So maybe you can easily picture out, visualize. And what is asked, what is required is this side here. Let's call this side A, this side B. What is A and B that will give the maximum volume? So A is represented by 3 minus 2x and B is represented by 4 minus 2x. What is A and B that will give the most volume? So what is maximized here is the
Volume po.
volume of or maximum volume. Okay. So how do we start? We start with the volume of the box. We can immediately state it in terms of this particular dimensions. 3 minus 2x times 4 minus 2x times x. All in terms of x. Wala na tayong substitution dito. We just have to multiply this. You can use product rule wherein you multiply 3 terms, or you can use FOIL method first for these two expressions and then distribute x and then derive. Okay? And it is shown that in your nuble, you arrive at an equation na 12x squared minus 28x plus 12. This is a quadratic equation that can be reduced to 3x squared minus 7x plus 3. Because this is divisible by 3. No, divisible by 4. Divisible by 4. After deriving, this is after derivation. This is what is, so this must be equated to 0. This is a quadratic equation, so you use quadratic formula to arrive at a value of x equal to 0. Dalawa. Because you have two values for x. Which one is the most practical? The one that is most practical is for x to have a value of 0.57 meters. Is this in meter? Walang sinabi. Feet. This is in feet. Because the other one, which has a value of 1.77, is not practical because it will exceed the 3 feet if it is 1.77. Therefore, you use the value of x equal to 0.57, this one, instead of 1.77. And you get the maximum volume. In this case, the volume is 3.03 feet. Okay, you review the nuble and that's it. So I hope I have illustrated clearly the problems 1 to 5 in your module class.